And in today's episode, among other things, you'll see a new digital DNA project that aims to keep human identity alive in humanoid robots after our deaths. And speaking of humanoid robots, the T-800 is already being sold. And with that, China is starting the era of commercial humanoid robots. Scientists have shown cockroach cyborgs that have become amphibious, thanks to a new diving suit designed for them. Elon Musk's Starship launched the Starlink satellite and performed a water landing, which was considered the most successful so far. Tron 2, this one here, has learned to work on its own, my friends. It uses a kit that turns it into an autonomous worker. Let's get into all of this and a few more things about new technologies. Hello, impressed ladies and gentlemen. I'm Realidade Impressionante, and you're watching Realidade Impressionante. And I'm still your internet here, but you can work with it. Let's go. And what if, in the future, a part of your personality could continue to exist, even after you had died? And no, it's not just in the form of videos or photographs like we have today, but as an artificial intelligence capable of talking, teaching, answering questions, and even controlling a humanoid robot, using everything it learned during its own life. This is the project proposal presented by an American company called Veteran First for America. Although the initiative is still in a conceptual stage and many of these promises depend on scientific and technological proof, it raises a very fascinating discussion. Will it really be possible one day to digitally preserve aspects of our identity, of human identity? The project is part of a platform called KAI-QAIX, which proposes to expand this technology to a much broader ecosystem, involving robotics, healthcare, artificial intelligence, and highly automated cities. One of the most curious concepts is precisely what's called digital DNA. Despite this name, it has nothing to do with biological DNA. The idea is to create an extremely detailed digital copy of a person using a haptic suit equipped with 40 sensors distributed throughout the body. While the user performs different activities, the system records movements, postures, vital signs, motor patterns, professional skills, and various other behavioral information. This data would then be processed by an artificial intelligence system to create a digital profile capable of reproducing certain aspects in the same way that person acts, reacts, and performs certain tasks. The creators say this profile could be added to humanoid robots or holograms, enabling use by families or holistic institutions. Holographic, allowing family members or even institutions to have a digital version of that individual there. Weird stuff, huh? Okay, so
Bizarro negócio, hein?
It's worth noting, however, that this proposal is still very far from representing a real transfer of human consciousness. The technology described aims to reproduce patterns of behavior and accumulated knowledge. In other words, to be very clear, there is no scientific evidence that it is actually possible to copy memories, emotions, or subjective experiences that characterize a person's consciousness. Basically, what they are saying is that the system can indeed learn to imitate someone, but that doesn't mean a person will continue to exist inside a machine. Besides this concept, the project presents a very ambitious vision for the future. The proposal includes the creation of hundreds of highly automated communities, where robots and artificial intelligence systems perform most of the daily tasks, from urban infrastructure to public services, while human professionals would only supervise situations that truly require specialized judgment. You know, I always tell you the truth here, right? So far, there is no public evidence that this technology can truly reproduce a person's identity or even offer these capabilities at scale. Many of these promises remain in the conceptual stage and will need to overcome a lot of challenges, including scientific, technical, ethical, and legal ones. Why not? All of this before any practical application, if they ever manage to do it, right? I think they will. And the Chinese manufacturer, Engine AI, has just shipped its first commercial batch of general-purpose humanoid robots. And this marked a new phase in the global race for automation. The model's name drew the most attention from internet users in this announcement. T-800, an inevitable reference to the Terminator franchise. Coincidence or just a marketing strategy, the fact is that the era of commercial humanoid robots seems to have finally begun. The Chinese T-800 was developed with a structure designed to operate naturally in environments built for us human beings. At about 1.7 meters tall, it can move through hallways, go through standard doors, use utensils that already exist in homes and businesses, and even fight another one, as we saw in a previous episode here on Impressive Reality. Another very important aspect is the manufacturing process itself. Engine AI claims that they have simplified several elements of this mechanical architecture to make large-scale continuous production easier. Instead of manufacturing a few highly specialized units, the goal is to reduce costs and turn humanoid robots into products that are increasingly accessible for companies, and of course, eventually for regular consumers as well. The company emphasizes that their goal is exactly the opposite of what's portrayed in the movies, you know? The focus of the project is on domestic assistance, operational support, and collaboration with human beings. Even so, the reference to T-800 shows how popular culture continues to influence the way we see the arrival of these machines in our daily lives. This launch comes amid rapid acceleration in the global industry. Companies like Tesla, Figura AI, Unitree, and several other Chinese manufacturers have been rapidly increasing their investments in humanoid robots, while artificial intelligence platforms and the Grok project are still influencing the way we see these machines in our daily lives. Other artificial intelligence platforms, such as NVIDIA's Growth project, aim to create artificial brains. Several other companies, like Figura, are also part of this industry, and this competition is no longer just about who builds the best machine or the best hardware, if you prefer, but about who will develop the complete ecosystem that will give intelligence to millions of these machines, my friends. And yes, there are still challenges related to cost, autonomy, and safety, why not? But the direction seems clear, right? Humanoid robots are indeed starting to play a real role in the global economy. And that's only going to increase, you know? And what sounds more terrifying than a cyborg that's part cockroach, part robot? Definitely one of those that can also breathe underwater. This technology has just been developed by researchers at Nanyang Technological University in Singapore in partnership with Waseda University in Japan. They created a specialized diving suit for cyborg cockroaches capable of continuously supplying oxygen to these insects, turning them into small amphibious biohybrid robots. Yeah, things are getting stranger and stranger. The goal isn't to create a new species of super insect, at least that's what they say, but rather to develop a tool for search and rescue operations in environments where conventional machines still face enormous difficulties. First, my friends, let's clarify what a cyborg cockroach is. Unlike a fully mechanical robot, it is still a living insect. Researchers simply attach a small electronic platform to its body, equipped with microcontrollers, a battery, and a wireless communication system. Small electrodes are placed on the antennae and send low-intensity electrical impulses that are able to influence the insect's natural behavior. Since cockroaches instinctively turn away when one antenna touches an obstacle, stimulating just one side makes these insects change direction. This allows them to be guided remotely. Yeah, I know. This concept might seem strange, but it offers advantages that engineering still hasn't managed to reproduce in robots of similar size. Meanwhile, a fully mechanical micro-robot needs to carry motors, gears, and batteries, which are relatively heavy. By contrast, cockroaches use their own muscles to walk, climb walls, squeeze through extremely tight spaces, and withstand impacts that would easily destroy conventional electronic equipment. Since the onboard electronics consume very little energy, this system can operate for days or even weeks. And this new advancement further expands these capabilities. The researchers replaced that traditional rigid backpack they used not long ago with a flexible and waterproof suit that follows all the insect's natural movements. Integrated into this high-tech suit, there is a small oxygen generation system composed of a 3D printed layer, a sponge coated with manganese dioxide, and a small amount of diluted hydrogen peroxide. When the chemical reaction occurs, the peroxide breaks down into water and oxygen, and this gas produced is conducted through tiny silicone tubes directly to the cockroach's spiracles, the small openings responsible for the insect's breathing. In practice, the suit works like a miniature oxygen tank, but instead of storing compressed gas, it produces its own oxygen continuously as the reaction happens, thus reducing the weight and size of all this contraption. During laboratory tests, the cockroaches remained active for up to 3 years in fully submerged environments or with extremely low oxygen levels, maintaining almost all of their mobility just as the guys wanted. Building the biggest rocket ever would already be a major challenge, right? But Elon Musk's SpaceX is trying to do something even more ambitious, which is to create a vehicle capable of taking off, launching payloads, returning to Earth, and being reused repeatedly, just like airplanes today. And with each new flight, Starship gets a little closer to that goal. Now, during its 13th integrated test, the system reached an unprecedented milestone by launching its first operational Starlink satellites, reigniting its engines in space, and performing its most controlled re-entry to date. Although not everything went exactly as planned, the mission showed that the largest rocket ever built continues to evolve very quickly. However, the mission was not meant to put these satellites into their final orbit. After separation, they were released on a suborbital trajectory in order to validate the entire payload deployment system. And yes, they did establish communication with the Starlink constellation before re-entering the atmosphere and disintegrating as planned. The focus was to prove that Starship is already capable of carrying out a complete operational launch mission, a fundamental requirement, so that in the future it can regularly transport the next generations of the Starlink network. Another important moment took place in space. The engineers once again reignited the Raptor engines. This is an essential maneuver for future orbital missions, as well as trips to the moon and, in the future, for missions to Mars, which is Elon Musk's dream. The ability to shut down and reignite engines with precision allows for trajectory corrections, changing orbits, and performing complex maneuvers during long-duration flights. And then came the most critical phase of this mission and testing, the return through Earth's atmosphere. SpaceX deliberately subjected Starship to extremely demanding re-entry conditions. The idea was to test the limits of the heat shield, the control systems, and the vehicle's structure. And according to the company, the upper stage performed its smoothest descent to date, remaining practically intact after splashdown in the Indian Ocean. This result represents a very important advance in the quest for complete reuse of the spacecraft, since surviving the intense atmospheric heating is one of the greatest challenges in aerospace engineering. However, not all objectives were achieved. During the return of the Super Heavy, some engines failed to reignite for the landing burn. Without enough power to slow down, the huge booster hit the water harder than expected and ended up being lost. Even so, for SpaceX, this kind of occurrence is part of the development philosophy adopted by the company. Each flight is treated as a full-scale experiment, whose main goal is to collect data that allows the project to be improved the next day. And the Chinese company Line Lightning X Dynamics presented the new autonomous mobile manipulation kit. This one turns the Tron 2 into a robot capable of seeing, navigating, and manipulating objects in an integrated way. The main differentiator of this new system is that it combines full-body control with three-dimensional perception in a single package. Instead of treating locomotion and manipulation as independent tasks, the robot coordinates its entire body at the same time. While its sensors continuously analyze the environment, its arms, legs, and joints work in sync to carry out a single mission. In practice, this means that Tron 2 can perform tasks much closer to what humans do in everyday life. It identifies objects left on the floor, approaches them, automatically calculates the best body position, bends down to pick them up, and returns to its working position without losing balance. In the video presented by the company, the robot also performs tasks such as watering plants, carrying objects, and making autonomous deliveries both indoors and outdoors, thus demonstrating a continuous sequence of actions, not just isolated movements. And this autonomy depends on a sophisticated set of sensors. And the kit incorporates three-dimensional perception of the environment, allowing the robot to build maps in real time, locate its own position, and plan its route without relying on external infrastructure. All this architecture was developed with embodied AI in mind. In this approach, artificial intelligence doesn't just mean answering questions or interpreting images. It needs to understand the physical space, control the robot's movements, interact with objects, and make decisions on its own while performing real tasks. And the result is a very important change in the evolution of robotics. Instead of creating machines specialized in just one function, companies like Line X Dynamics are already starting to develop platforms capable of learning different activities within the same environment. This paves the way for applications in logistics, industrial handling, inspection, agriculture, hospitals, and even domestic assistance, where a single robot will be able to perform several tasks throughout the day. And researchers at the Okinawa Institute of Science and Technology in Japan have developed a system that tries to make machines learn the way children do. Now the robots explore, play, make mistakes, and turn curiosity into knowledge. And according to the guys, the result was surprising. Besides learning almost twice as fast, the robots started to show spontaneous behaviors that are very similar to those of our children. Unlike large language models, which learn by analyzing huge amounts of text to predict the next word, this project uses an architecture inspired by the workings of the human brain itself. To achieve this, the researchers combined this architecture with reinforcement learning. The robots received a reward when they correctly completed a task, which was based on language. But they also received an internal reward whenever they explored unknown situations and managed to learn something new. In other words, they were encouraged not only to get things right, but also to figure out what to do. And the effect became apparent quickly. Even after mastering the proposed tasks, many robots continued to explore the environment on their own initiative. They knocked over objects, tested different combinations, and performed actions that hadn't been requested. At first glance, it seemed like just useless behavior, but this kind of so-called play ended up speeding up learning of language, thus reinforcing a hypothesis that is already widely discussed in child psychology. Playing is also a way of learning. In addition, the researchers discovered another impressive result when they varied the amount of linguistic stimuli available. Robots trained with only 48 different combinations were able to correctly generalize to about 25 of the new instructions, whereas those exposed to 180 combinations achieved about 85 correct generalizations. This shows that the diversity of experiences was much more important than simply repeating the same examples countless times. And perhaps the most curious discovery in all of this came when the scientists deliberately invented some language rules. Initially, the robots learned these exceptions correctly. Then they started to create their own general rules, and because of that, they temporarily began to make mistakes in exactly the things they used to get right. And only later did they get it right again. This behavior reproduces the famous learning curve observed in children, who are often inventing their own ways before they can finally master irregular verbs or language itself. Who hasn't seen a child babble words thinking they're saying daddy? You were practicing, my friend. And when we think about mining, we usually imagine those giant trucks, excavators, human workers facing the heat and dust, and high-risk environments, right? But there's a transformation happening right now in this sector. At a copper mine in the state of Utah in the United States, the Boston Dynamics quadruped robot dog has gone from being just an inspection machine to becoming part of the operations landscape. Instead of just walking around the site, it continuously collects data, feeding the artificial intelligence system and helping those responsible for the mine make the best decisions. The project is led by Marina Minerals, a company that defines itself as the world's first mining company built with a software-first philosophy, where data becomes as important as the ore itself. Each patrol carried out by the robot is part of a much larger system called Marina OS, a platform that gathers information from sensors distributed throughout the mine, analyzes this data in real time, and helps operators optimize every stage of production. In practice, Spot follows the inspection routes completely autonomously. During this journey, its cameras and sensors capture images, temperatures, sounds, and also other information about the equipment, pipelines, and refinery structures. Instead of relying on manual inspections carried out only by humans a few times a day, the mine is now monitored continuously, allowing anomalies to be identified long before they turn into failures or serious accidents. According to what they said, their goal is not just to automate individual machines, but to connect the entire production chain through artificial intelligence, transforming a traditional operation into a system capable of continuously analyzing its own performance and adjusting these processes with much less human intervention. If you like this episode, leave a like and check your subscription. It really helps. 2 new suggestions are on your screen. Click one and I'll see you next time. Thanks, bye, and see you soon. I'm waiting for you, okay?